Okay. All right, so this other one, we've got this car that we're trying to stop, and the question wants to know what's the smallest coefficient of friction that would stop it in time. Okay? Very similar setup. The big difference is this. This time we don't know the force. Okay? So here's what we know. We've got this car. Driving along. It's got a velocity of 25 meters a second. And we want it to, slow down and stop. And our goal is within a displacement of 80 meters, we want it to get to a velocity of 0. And the question is, what does the coefficient of friction have to be? Now, it doesn't specify whether it's static or kinetic, and it depends on whether or not the car is skidding or not. So you really could interpret it either way. But regardless, force of friction is always just coefficient times normal force, right? Whether it's static or kinetic, basically. Does that make sense? So if you thought about it as static, great. If you thought of it as kinetic, great. Either way, it amounts to the same calculation. Okay, so I've already identified the 2 points in the motion, at the beginning when it's moving and at the end when it's not. So the next thing I want to do is think about energy. Let's use this mass of 1,000 kilograms. So over here at the beginning, I can find my kinetic energy. Just do 1/2 mv squared. So if you do that, it gives you 312,500 joules. What's the kinetic energy going to be at the other end, you guys? 0, right? All right. What other types of energy do I need to worry about? Friction's not an energy, it's a force. What about GPE? Yeah, it's 0 the whole time, right? Or whatever it is, it doesn't change, so, whatever. Yeah, so I think that's it, right? Cool. All right, everybody good up to there? All right, so if we call our GPE 0, oh, well, then that means my total energy that the car starts with is this, and the total energy that the car ends with is 0. And so now I'm kind of stuck. So what do we know about the total energy? It's changing. Oh, and in fact, I know how much it changed by, right? So let's see. So my change in total energy is going to be what? Good. Negative 312,500 joules, right? Just by doing final minus initial, 0 minus 312. Cool. All right, so that's the change in total energy. Oh, this is also equal to my work done by non-conservative forces, right? Well, what's the non-conservative force in this problem, you guys? Name the non-conservative force. Friction, right? Either static or kinetic friction, right? All right. So I found the work of friction. What would probably be a good next step? Put it into the equation. Which equation? I need to ban the sentence. Put it in the equation. There's like a billion equations. Yeah, work is force times distance, right? So let's see. Our work of friction should be our force of friction times our displacement, right? So we get negative 312,500 joules. I'm sorry, Alex. Times 80 meters. So our force of friction, if you figure it out, ends up being negative 3,906.25, I think, if I divided that right.
Yeah.
Cool. Yeah, Lauren? I'm sorry? Oh, good, good. You can, but point for me. What direction is the car going? That way. And which way is the force of friction? That way. Well, I mean, you know the force of friction has to be pointing in a negative direction, so just make your answer negative. When you use this equation, as soon as you put that cosine theta in there, all the numbers are assumed to be positive. So you would have to get rid of this. Wait, let's see. Oh wait, let's see. Cosine of 180. Yeah. Oh, right. Yes. Yes. Sorry. Because as soon as you put this cosine theta in there, the assumption is that you're putting only positive numbers in there. Okay. I need to do a better job of that. Do you understand that the force is in a negative direction? So just go with that. Milena, what's up? You good? I mean, you know it's got to be in a negative direction, so. Okay, all right, so now we're done, right? Force of friction is coefficient of friction times normal force. Your normal force is just your weight, right? So you get 3906.25 equals your coefficient times your normal force is just mg, right? Earth mass times 9.8. Sorry, here. Where did I get that? So here's your car. It's 1,000 kilograms, right? So your gravity's 1,000 times 9.8. Oh, that means my normal force also has to be 1,000 times 9.8. Okay. LaShawn and then Noah. Sorry. Go ahead, LaShawn.
Why did you say you don't need the mass?
So you can solve the problem, and instead of multiplying everything by 1,000, just leave it as m. And when you get back to this last step, this thing ends up being something times m, and the normal force is something times m, and the m's cancel. That really is more of an AP level style problem, so I wouldn't expect you to do that on a test or anything. So, i.e., I wouldn't stress about it. Cool? Noah, who I keep wanting to call Nacho, does that bother you? Okay. What? Does it bother you if I call you Nacho?
Oh, no, I like
Oh, I see. Okay. All right.